Have you ever wondered that for thousands of years, our ancestors may have gazed up at this very same sky without even having a single word to describe the color blue? Sounds crazy, doesn't it? A color that takes up half of our vision every day, a color we consider obvious and essential, was once a blind spot in the language and perception of entire civilizations. Welcome back to Origin Stories. I'm your companion on this journey to uncover the origins of the universe and everything in it. Today, we'll answer a question that seems almost childish, one that most of us have probably asked at least once in our lives. Why is the sky blue? But this isn't just a dry physics lesson. Behind this simple question lies an epic story of human perception, a saga that stretches across millennia, from myths about gods and giants to groundbreaking experiments in the labs of history's greatest minds, and ultimately to the discovery of how our own brains paint the world around us. Our journey will take us from ancient Egypt to Isaac Newton's laboratory, from Greek islands to outer space itself. Together, let's lift the veil on a mystery hidden in plain sight, something we see every single day, yet remains profoundly magical. Before telescopes, before the laws of physics, what did people do when they looked up at the heavens? They told stories, they wove myths. For the ancient Egyptians, the sky wasn't an empty void. It was the body of the goddess Nut, mother of the universe. Every evening she swallowed the sun god Ra, and every morning she gave birth to him again. The sky was a living being, a divine protector. And the color blue? Perhaps it was the color of life itself, reflecting the sacred Nile River. The ancient Greeks had another story. The sky was Uranos, one of the primordial gods, father of the Titans. It was a solid bronze dome held aloft by Atlas as punishment. For them, the heavens were strong, tangible, not a fragile layer of air. But here's where the mystery begins. In the texts they left behind, from Homer's Odyssey to the Old Testament to India's Vedic hymns, linguists noticed something astonishing. They described the sky as bronze-like, iron-like, star-filled. They had words for black, white, red, yellow, but almost none of these civilizations had a distinct word for blue. Homer described the sea as wine-dark, honey as green. Hard to believe, right? William Gladstone, a 19th century British Prime Minister and classical scholar, was among the first to spot this. He counted. In the Odyssey, black appears nearly 200 times, white about 100 times, red 13 times, but blue? Virtually none. This became known as the blue gap in ancient languages. So, were ancient people colorblind? Of course not. Biologically, their eyes were the same as ours. The difference lay in culture and perception. Think about it. In nature, blue is rare. Most fruits, animals, and plants don't have it. The only clear, ever-present blue was the sky itself. But because it was always there, the backdrop of everything, perhaps they didn't feel the need to give it a name. Just like we don't have a word for the color of air. It wasn't until humans learned to make blue dye that the color truly entered culture. The Egyptians were the first, grinding lapis lazuli or creating synthetic Egyptian blue from copper and sand. Blue became a symbol of royalty, divinity, and immense wealth, far too precious to waste on something as ordinary as the sky. So for thousands of years, the sky wasn't really blue. It was simply the sky, a divine dome, a cosmic shelter. This worldview only began to shift when humanity turned its gaze away from the gods and down toward nature. searching for answers not in myth, but in the fabric of reality itself. And that revolution began not with thunder, but with a prism. 1666, the Great Plague was ravaging London. Universities closed. A 23-year-old Cambridge student named Isaac Newton returned to his family home in Woolsthorpe. This became his annus mirabilis, his year of wonders. In solitude, Newton's genius blossomed. Laws of motion, universal gravitation, and an experiment that forever changed our understanding of color. At the time, people believed colors came from mixing light and darkness. White was pure light. Add a touch of shadow and you got red, green, or yellow. Prisms, they thought, simply stained pure light. Newton disagreed. He proposed something radical. White light isn't pure at all. It's a mixture of every color. In a dark room, he let a single beam of sunlight pass through a glass prism. A brilliant rainbow exploded across the wall. That much was known. But Newton went further. He placed a board with a slit, isolating just the red light, then passed it through a second prism. If the old belief was correct, the prism should change red into some other color. But no, red stayed red. This proved that colors were fundamental, not distortions. The prism didn't create color. It merely bent light, separating the components hidden within white. To prove it beyond doubt, Newton reversed the experiment, recombining the rainbow with a second prism until it merged back into white. A stunning revelation. White light is not purity. It is a symphony of all colors. Naturally, people wondered, if light splits into colors, then maybe the atmosphere splits sunlight too. The sky must be blue because air scatters blue light. Even Newton thought so. He imagined dust or water vapor reflecting blue light more than others. Sounds reasonable, right? But there was a flaw. Even in the cleanest, driest skies, the blue remained. And why then were sunsets red? Newton gave us the first key, the nature of light. But the door to the mystery stayed locked. Humanity needed nearly 200 more years. The 19th century, the age of great discoveries, electricity, radio waves, evolution. Yet the blue sky remained an unsolved riddle. Enter John Tyndall, a brilliant experimentalist. Unlike armchair theorists, he wanted to recreate the sky in the lab. He filled a tube with pure air and shone white light through it. Nothing happened. But when he added a bit of fine dust, magic occurred. From the side, the light glowed a brilliant blue, like the sky itself. From the far end, it glowed orange-red, like a sunset. This became known as the Tyndall effect. You can see it today when sunbeams illuminate dust floating in a room. Tyndall was close, but not quite there. His experiment required dust. Yet even in perfectly clear air, the sky was blue. What else could scatter light? That's when Lord Rayleigh, John William Strutt, stepped in. He attacked the problem with mathematics. What if it wasn't dust, but the air molecules themselves, nitrogen, oxygen, that scattered light? He discovered a law. When particles are much smaller than the wavelength of light, scattering is inversely proportional to the fourth power of wavelength. In simple terms, shorter wavelengths scatter far more strongly than longer ones. Blue light scatters 16 times more than red. At last, the answer. The sky isn't blue because air is blue. It's blue because invisible molecules fling blue light across the heavens, leaving red and yellow to pass through. The sky is nature's light filter, a cosmic dance between sunlight and air. If violet has an even shorter wavelength than blue, why isn't the sky purple? Two reasons. First, the sun emits less violet light than blue. And second, our eyes. Human retinas have three types of cone cells, most sensitive to red, green, and blue, not violet. Violet light partially stimulates both blue and red receptors, which our brains interpret as blue. So the sky's color is not only physics, it's also biology, a compromise between atmosphere and perception. And this scattering gives us another gift: sunsets. At noon, sunlight takes the shortest path through the air. Blue dominates. At sunset, the sun is low. Its light travels through a much thicker atmosphere. By the time it reaches you, nearly all the blue has been scattered away, leaving behind the long-distance runners: red, orange, gold. Sunset is the sky's way of saying, here's what's left after the blue is gone. On the moon, without an atmosphere, the sky is pitch black, even at noon. On Mars, with its thin, dusty, iron-rich air, the daytime sky is butterscotch. But at sunset, something miraculous happens. The horizon glows blue, the opposite of Earth. The science explains the color, but the story isn't complete without the culture. Blue was once the rarest, most precious color. In the Middle Ages and Renaissance, ultramarine, lapis lazuli from Afghanistan, was the most expensive pigment on Earth. It was reserved for the holiest figures, like the Virgin Mary. Blue meant divinity, purity, heaven itself. Centuries later, when cheap synthetic dyes arrived, blue spread to the masses. Blue jeans were born. The sacred became everyday. With this, its meaning shifted. The sky was no longer God's dome, but an endless expanse. Freedom, but also loneliness. In English, to feel blue means to feel sad. The blues, a whole genre of music, carries that weight of longing. Blue became not only the sky above us, but also the emotions within us. Today, blue is the world's favorite corporate color, chosen by banks, tech giants, and governments. Why? Psychology. Blue conveys trust, calm, intelligence, stability. When you see a blue logo, your subconscious whispers, "This is safe." And in the 21st century, perhaps blue has gained an even deeper meaning, a symbol of a healthy environment. A clear blue sky is no longer guaranteed, but a fragile gift, a reminder of the planet we must protect. So, from a simple question, why is the sky blue, we've uncovered a grand tale. A story of myth, where gods stretched across the heavens. A story of science, where Newton, Tyndall, and Rayleigh unlocked the secrets of light. And a story of culture, where one rare color transformed from divine to everyday, from sacred to emotional. Next time you look up, don't just see the blue, see the dance of countless air molecules scattering sunlight. See humanity's journey across thousands of years to understand that dance. The sky isn't just empty space above us. It is a mirror, reflecting the curiosity, the science, and the soul of humankind. And that, perhaps, is the most magical truth of all. Thank you for joining Origin Stories on today's journey all the way to the very end. If this video has given you a fresh perspective on something that once seemed so familiar, don't hesitate to give us a like to help spread this knowledge even further. And if you're not yet part of our community, make sure to hit the subscribe button and the notification bell so you won't miss any future adventures into the origins of the universe and everything within it. At Origin Stories, we believe that every question is a doorway to the cosmos. So, what's the next mystery you'd like us to unravel together? Why is the sea salty? Why do we dream? Or perhaps another enigma entirely? Share your ideas in the comments below. We read every single one of them. For now, goodbye, and we'll see you in the next episode.